Good evening, everyone. I'm Sathwika from CSC department. In this video, I'm going to give a presentation on object-oriented programming in Python. So we're going to focus on this following concepts in this presentation. There are differences between procedure versus object-oriented programming, features of object-oriented programming, fundamental concepts of object-oriented programming in Python, and what is a class, what is an object, methods in class, instantiating objects with init and self, encapsulation, data abstraction, public protected and private data, inheritance, polymorphism, and operator overloading. So our prime agenda is to focus on the history of object-oriented programming, objects and classes, and the basic concepts that encapsulation, inheritance, abstraction, polymorphism, and operator overloading, method overriding, and what is the need of object-oriented programming, components of object-oriented programming, and all the basics concepts like class, objects, inheritance, and types of inheritances. So, first of all, what is the difference between procedure-oriented and an object-oriented programming? Procedural programming, it creates a step-by-step program. Such that it guides the application through a sequence of instructions. Procedure programming, it follows a sequence of instructions, and each instruction, it has to be executed in certain order. And this procedural programming, it also focuses that all the algorithms are executed with the functions in data that the programmer has access to, and we can able to modify that. In object oriented programming, it is more similar to the way the real world works, and it is analogous to that of human brain. And here each program is made up of many entities called objects. Instead, a message must be sent requesting the data, just like people must ask one another for information, but we cannot actually see what is inside each other's head. So in the same way, object oriented program works. Here, only the message is sent requesting the data. Next, object-oriented programming, it is mainly a program design philosophy. It uses a different set of programming languages than old procedural programming languages like C and C++. And everything in this object-oriented programming is grouped as self-sustainable objects. Here, we can gain reusability by means of 4 main object-oriented programming concepts. So in object-oriented programming, programmers, they define not only the data type of a data structure, but also the types of operations or methods that can be applied to the data structure. So in this way, the data structure becomes an object that includes both data and functions. That is methods in one unit. In addition to that, programmers, they can create a multiple relationships between one object and another. For example, objects can inherit characteristics from other objects. So this is an example in order to support this statement. Now, what is the key idea in object-oriented programming is that the real world can be accurately described as a collection of objects that interact. And the focus of object-oriented languages is not on structure, but it is on modeling data. Programmers code using these blueprints of data models called classes. Here, classes are termed as the blueprints of data models. Now, in object-oriented paradigm, it is a programming methodology that promotes the efficient design and development of software systems using reusable components that can be quickly and safely assembled into larger systems. Here, the main aim of object-oriented programming is to implement real-world concepts like object, classes, abstraction, inheritance, and polymorphism, where object is nothing but a real-world entity. Classes are termed as blueprints or templates. Abstractions is nothing but visibility controls. Inheritance is also known as backward compatibility or parent-child relation. And polymorphism is Basically, it is defined as many forms. Poly, in the word itself indicates is many. Morphism, it depicts that it is made of many forms. The word morphism, it indicates that it takes many forms, not a single, but it takes multiple forms. Like, we're going to learn about all this concept in detail in upcoming slides, but these are the like what these are the main pillars of object oriented programming. All these concepts are very important in order to understand object oriented programming. So why is this necessity to learn about object oriented programming? It is essential because we are breaking down requirements into objects with responsibilities but not in functional steps. Now here procedural approach, it indicates as object oriented approach, and it is easy to model real things, and in order to make these software projects more manageable and predictable, for more reuse of code and to prevent reinvention of wheel every time. So here we can reuse the code again and again, and there is no need to reinvent some other new code in the same program. So what are the advantages and disadvantages of object oriented programming? Coming to advantages part, as I have stated earlier, it is useful for code reuse and recycling, and improve software development productivity, improve software maintainability, faster development, lower cost of development, high quality software, and encapsulation. Encapsulation, where you can wrap up the data into a single unit. We can be more familiar in the upcoming slides. And what are the disadvantages of object oriented programming is that it is a steep learning curve, and it could lead to larger program sizes, and it could produce slower programs. So what are the features of object oriented programming is that it has the ability to stimulate with real world event much more effectively, and code is reusable, thus less code may have to be written, data becomes active, and it is better able to create GUI, which is known as graphical user interface applications, and the programmers are able to produce faster, more accurate, and better written applications. Now, what are the fundamental concepts? As we have seen earlier, there are four major principles of object-oriented programming are encapsulation, data abstraction, inheritance, and polymorphism. Now, so the suitability of object-oriented programming is that it is good in complex projects or modular type of systems, and it allows simultaneous system development teams, and also could aid in agile system providing and developing environments like extreme programming. Now, the basic terminology that is involved in object-oriented programming is object, method, property or attribute, and class. So object is nothing but it's usually a person, a place, or a thing. Method, it is an action performed by an object, and property or attribute is the characteristics of a certain object, where class is a category of similar object such as automobiles, and it does not hold any values of the object's attributes or the properties. So if we consider an example, let's say mobile. Mobile is a class, and the different brands which are involved, like Samsung, iPhone, Vivo, etc. These are the objects or the attributes. Now, so in the basic concepts, we are going to learn about what is an object, what is a class, inheritance, polymorphism, encapsulation, and data abstraction. So coming to classes and objects. What is a class? A class is a prototype, idea, and blueprint for creating objects. And an object is an instance of class. So for example, in Python, we define classes which in turn are used to create objects. Now, a class has a constructor for creating objects. So class is composed of basically three things: its name, its attributes or properties, and the methods. So class is divided into two parts: the objects, which are termed as instances of the class, and the class properties, which belong to the class. And objects are further divided into instance properties, which belong to the object, now not the class, they belong to the object. And the class properties are further divided into methods. Methods are the functionalities of classes. So class is a blueprint or prototype from which objects are created, and a collection of objects, they have to be of similar type. So a class is a special data type which defines how to build a certain kind of object. And the class, it also stores some data items that are shared by all the instances of this class. Instances are objects that are created which follow the definition given inside of the class. And Python doesn't use any separate class interface definitions as in some languages. You have to just define the class and then use it. Now, a class is a data type that defines a template or a blueprint of an object. So in other words, a class refers to the category or type of objects. So your cat kitty, for example, is a type of cat, and your red Mercedes is a type of car. And you have a bank account is of a type of savings account. And a class, it has variables defining properties and methods defining behavior of its objects. So a class is a definition of objects with the same properties and the same methods. Now this is a class called bicycle, where you have initialized a speed, a gear, and a cadence. And we have to further, we have assigned a new value to gear, cadence, and speed. The speed is incremented, and then speed is also decremented. When you speed up, the speed gets incremented, and when you apply brakes, the speed gets decreased. I mean, this class bicycle is actually a class, and objects, in the sense the brands involved in the bicycle, they are termed as objects. And this all these, the gate, the cadence, the speed, are the functionalities of the class. Now, for the example, let's say we have an account called a bank account, and the account has got its own owner, balance, and account number and transaction log, where we'll deposit an account in interest rate, and the current account is overdraft limit. So this is the class, and these are all its functionalities. And let's say, let's consider X as a car. So it has a property, and it has also some methods. Like properties, it has got its own plate number, color, manufacturer, model, and gate type. And the method, whether it moves forward, backward, left, right, and whether it stops. So these are the functionalities and methods of a class. It has got its own class methods and class functionalities. And if we consider this is a class, mobile is a class, and different types of brands involved in it are called as objects. And the vehicle is a class, and the car, it has got its own plate number, cost, and color, the brand or the company's brand. All these are nothing but the functionalities of the vehicle car. Now the syntax is nothing but, let's just take an example of cat. So public class cat, here class cat is a class basically. And if we specify which type of cat, like kitten or a separate breed of the cat, then that is termed as an object. But here class, it's a common word we will define to all the classes, all the cat classes. So here class is termed as cat, and the color, its breed. So all these are the functionalities of this cat. And it has got number of legs, um, what it has got its own sound as a functionality. So all these, here class is a name of the cat, is a name of the class. And what it has got its own color, it has got its own breed, and the number of legs are termed as variables. And what it says, meow and I'm a new cat, it is a constructor. This part is a constructor part. And the methods, like public void meow, and the system, it has to print meow on demand. So this displays on the output screen. This is nothing but the methods. Here the color and breed are variables and the methods that get, breed, meow and cat eats, it is a method. Now, coming to object. What is an object? Objects are the basic runtime entities in an object-oriented system. They may represent a person, place, a bank account, a table, or data, or any item that a program must handle. Now, when a program is executed, the objects interact by sending messages to one another. Here, objects have two components. They are data and behavior. Data is attribute and behavior is nothing but the methods. Object is simply defined as an instant of class. So, an object, it is a person, let's say, so object, it is a person, place or concepts, and it is composed of characteristics like data, and it has got its own behavior, that is operation. Now, almost everything in this world, it can be represented as an object, right from a flower, a tree, an animal, a student, a professor, a desk, a chair, classroom, building. It can also be a university, city, country, the world, the universe, subjects such as CS, IS, math, history, and an informative system like financial and legal, etc. So an object is a self-contained component with, it has got its own methods or behavior and properties or state. So objects are the real world manifestation of a class. Like your house, it is a manifestation of the architect's blueprint. So a car is a real object of a type car. Now objects, they occupy memory location at runtime, where class, they do not occupy memory location at runtime. Now, let's think of a class like the Mercedes blueprint and the object like your brand new Mercedes. So, if we consider class as car, then Mercedes, it's an object which comes under the category of car. Now, informally, an object, it represents an entity, either physical, conceptual, or software. So, it can be a physical entity like this of a truck, and then conceptual entity like chemical processes, and software entity where we have seen this linked list. So the example involves, suppose let's look at a student data, and the student has got their own name, their address, marks. So this is the data of the student, and the methods are total and the average. This is the representation of an object student. And coming to car, the representation of object car, the data involved is its color and cost, and the methods are driving or something related to that of car, whether it may be the driving a license related to that car and related to the person, the owner of the car, basically. So these are the methods. Now, coming to more formal definition of an object is a computational entity that encapsulates some state. It wraps up the data into a single unit, and it is able to perform actions or methods on the state. Now it communicates with other objects through the message passing, and an object, it is a class when it comes alive. Now let's consider Homo sapien, it is a class, and now John and Jack are objects. And also animal is a class, and Snowball the cat is an object. So vehicle is a class, and my neighbor's BMW is an object. But galaxy is a class, but Milky Way is its object. Now, each copy of an object from a particular class is called an instance of the class. And the act of creating a new instance of a class is called instantiation. So now the technical contrast between object and classes, where class is a data type and object is an instance of class. It class generates objects, whereas object, it gives life to class. Now class, it doesn't occupy any memory location, but object, it occupies memory location. A class, it cannot be manipulated because it is not available in memory except static class. So object, it can be manipulated, and object, it behaves as a class in runtime. So let's consider this example like time, hour, minute. If it is considered as a class, then the attributes or methods which are involved in time, like say we have assigned a value to hour, like say some 8 hours and 30 minutes. So these are the attributes and methods of the class, like hour and minute and void add minutes. So the attributes and methods are termed as objects. These attributes and methods of a class, they act as objects for this example. And okay, so now coming to the components of object oriented programming are class, object, and encapsulation, inheritance, polymorphism, abstraction, and so on. So now coming to class, as we have seen earlier, it is a group of objects which have some common properties, and it can be a template or a blueprint from which objects are created, and it is a logical entity. It is non-primitive data type, and it can't be physical, that it has got no memory space. Class members are access modifiers, objects, methods, instant variables, and constructors. Whereas an object is an instance of class, and any entity that has a state and behavior is known as an object. For example, a chair, pen, table, keyboard, bike, etc. It can be physical or logical. Now, programming representation of a class and object. Here we are defining a class student. Then we have initialized ID and the name. Like we have creating a main method inside the student class. And then static void, public static void in the main function of string. Now in this particular method, we are creating an object or instance. Now we are creating an object of student. Student S1 is equal to new student. And then we are actually printing the values of objects. Then we are displaying the details of the student onto the output screen by using this particular statement, system out print ln s1 dot name. Here we are accessing the member through some reference variable called the student's ID. Now, a class, it does not really exist, as it only provides a template, and we can therefore not perform operations on class as well. Whereas coming to an object, you can perform operations on objects. And a class is a data type. It defines a template or blueprint of an object, as we have seen earlier. Object is nothing but it is an instance of class, where the class, it doesn't occupy any memory location, and object, it occupies location at runtime. So objects, they need to collaborate, and they are useless unless they can collaborate together to solve a problem. So each object is responsible for its own behavior or status. No one object can carry out every responsibility on its own. Now, how do objects interact with each other? They can interact through messages. Now, how is this possible? Like, let's look at this example. Now, the object one, it has got its own property or method. Object two, object three, they also have their own property or methods. So, message is passed from object one and to object two, and then object two to object three, then finally from object three to object one. So, this is a recycling process. It goes on repeating. And then let's consider some example for object oriented interaction. And the order entry form, it wants order to calculate the total NOK value for the order. So this is an order entry form, and it transfers a message to another object to calculate the order total NOK value of the order, like the order entry form. So the class order, it has the responsibility to calculate the total NOK value. Now we are creating objects. So how to create objects? Here we have considered an example, a new point of 23 and 94 dimensions. and a new rectangle of 100 and 200 dimensions from origin 1. So this is the class, and these are the rectangle 1 and rectangle 2 are the objects of this class. And we have got another rectangle, second rectangle of dimensions 50 and 100. So each of these statements, it has got three parts: declaration, instantiation, initialization. Declaration, it is the code set in bold and are all variable declarations that associate a variable name with an object type. Whereas instantiation is a new keyword, a operator, it creates the object. And initialization is a new operator, it is followed by a call to a constructor which initializes the new object. Now creating an object. So here cat my kitty, it is an object of class cat, and cat my kitty is a declaration of object my kitty of class cat. So objects are created by using the operator new, which allocates memory for the object. The cat command, it invokes the no argument constructor we defined earlier. And when cat my kitty is new cat, this particular command it is run, then the following gets printed: meow, I'm a new cat. Since the meow, it is a sound, I mean, we have seen earlier in the syntax of class, the cat, it has got its own method and functionality. It has got its own sound, meow, and I'm a new class. That's the statement we have given in the constructor, and then it displayed onto the output screen. Now let's declare object references. So previously we have learned that to declare a variable, we have to just write type name, and we should type the name of the variable which we want to declare. And we have to also declare a reference variable on its own line. For example, point origin 1. So we have declared a reference variable that is for our reference. And what are actually variables, and what is the need to declare them each and every time? So a variable is nothing but a named field. It is containing information and that is associated with the class or object. For example, the color variable of a class cat, it indicates the color of the specific cat. So here we got two classes, I mean, two objects of a particular class cat. So we each and here each cat is different from one another. This is black, it has got its own functionality as an object, and this is white, it has got another functionality as an object. So these are nothing but a variable which actually separates the objects from one another in order to show the way they are different from each other. And for example, the color variable of a class cat, it indicates the color of the specific cat. And a variable, it has a data type indicating what type of variable, number, text, array, custom, etc. it is. So it basically differentiates the ways in which one object is differ from another. Now variables are classified into three types. They are local variables, instance variables, and class variables. Coming to local variables, a variable, it is declared inside a class or method constructor. It is called a local variable. And here other methods in the class are not aware of these variables. For example, consider the drink method of class cat drink. Now, milk quality, let's take some 10 float value, and the milk quality is a local variable of method drink. And coming to instance variables, these are the variables which are declared inside a class but outside of any method or constructor. Now these are called instance variables because their values are instance specific and they're not shared among instances. Example, the color variable of the class cat. Now coming to class variables, these are the variables which are declared inside a class with the keyword static. Now a single copy of a static variable, it is shared among all the instances of a class. Now, static variables are used to declare common properties, for example, the number of legs of a cat or the mileage of brand of cars, etc. Now, instances and static variables. So let's consider an example in order to understand this concept. So what is your color? Here, the cat which is in white color, it says that my color, it is my color, and this is none of your color. Like it has got its own color, which is different from another color, from another cat. It separates the both. The color, it is a feature of or a functionality which separates the cat from another cat. And here, the cat which is in black color, it states that you cannot hide number of legs. So that is a static variable in a class cat. So the number of legs of both the cats are same. So there's a feature or a functionality which is common in both the cats. It's not different. So this is a static variable. The variable which is static, which is the same in both the cats, is static variable. Now, what are the methods? So let's try to understand methods by considering the same example of a class cat. Methods, they are used to describe the behavior of the objects of a class, and a method is a set of statements which is referred to by name, and it can be invoked at any point in any program. It performs a logical unit of work, and for example, get mileage method in a class car is used to return a specific car's mileage. And in a cat example, meow and drink are the methods of the cat objects. So this meow and the drink milk are two functionalities of object class, and these are termed as a methods. Now, defining a method in a class by including all the function definitions within the scope of the class block. Now, there must be a specific first argument self in all of the method definitions, which gets bound to the calling instance, and there is usually a special method called init in most of the classes. So these two are the basic methods in a class. So this is a syntax of a method, and here public in get mileage, it returns type, it indicates the data type of the variable written by method, and the public void refuel, which is fuel value, it is nothing but a method name. So this indicates the parameter with which the method is invoked from within a program, and calculating the fuel is the body of the method which describes its functionality. Now, what are constructors? So constructor is a block of code which is defined in a class that initializes the newly created object. A constructor is structurally very similar to an instance method, but it is not a method as it does not have any written type. Now, a constructor, it is automatically called when the instance of a class is created. For example, public class cat. So this cat is a class, and we have to print meow, I'm a new cat. This is the statement that the particular statement which has to be displayed on the output screen. So the constructors, there are three types of constructors: the default constructors, no argument constructors, and the parameterized constructors. So default constructors, if a class does not have any constructor, like the compiler inserts a default constructor into the code. And a default constructor for class cat, it looks like this. And the body is empty. So this is a default constructor of cat. It has got nothing in its body, it's empty. And the default constructor, it is not inserted if we implement a constructor for class. So if we implement a constructor for a class, then it doesn't come under default constructor as it does not get implemented. And no argument constructors, in non-argument constructor, it is a one that takes no arguments or parameters. For example, cat, and we have just written a statement, I'm a new cat, and the sound is meow. So it has got no arguments and no parameters. So it is a no argument constructor. And the parameterized constructor, it is a constructor with arguments or parameters. It is known as parameterized constructors. For example, cat, string, and the message. These are the arguments, and this is a statement which is written in argument or a parameter, and this particular statement is displayed onto the output screen. Now, let's take a simple class definition and of that of a student to understand this class concept more clearly. So class student, it is a class representing a student. Then we have to define the class using init and self as arguments. And we have considered self name and age as the functionalities. And then we have to display that self age. And now we are defining the class name. It begins with a capital letter by convention, and whereas an object, it is a class based on Python built-in type. Now we are defining a method, like defining a function. It must have a special first parameter self, which provides a way for a method to refer to an object itself. And now instantiating a class. So the new operator, it returns a reference to the object it has created. This reference is usually assigned to a variable of the appropriate type, like point origin 1, new point of dimensions 23 and 94. And it can also be used directly in expression. For example, height of integer value. We are instantiating a rectangle of some height. So using this new operator, now we are instantiating the shape rectangle, and we are assigning a variable called height to it. So this is nothing but instantiating a class. Now let's have a look at initializing an object. Now here's the code for the point class, like public class point, and we are declaring two values of integer x and y. They're initialized to 0. And now we are declaring the constructor of public point of integers a and b, where x takes the value of a and y takes the value of b. In this way, we can initialize an object. Now, let's consider an example for this. We are considering a point of origin 1. New point is initialized, instantiated with the dimensions 23 and 94. And the result of executing this statement, it is illustrated in this figure. So since original value of the point it is over here, and now x and y takes the value 23 and 94, that it takes the value of a and b. That are nothing but a point object. Now we have to instantiate the objects with init. So init is a default constructor, and it serves as a constructor for the class. Now usually it does some initialization work, and init method can take any number of arguments. However, the first argument self, it is defined in the definition of the init. So self is an argument that has to be defined in init. It is treated as a special argument. And coming to self, the first argument of every method is a reference to the correct instance of the class. Now by convention, we name this argument as self. In init, self refers to the object currently being created. So in other class methods, it refers to the instance whose method was called. Now it is similar to the keyword in Java or C++, but Python, it uses self more often than Java uses. So you do not give a value for this parameter self when you call in method. Python will provide it. Now, although we have to specify the self explicitly, when defining this particular method, we don't have to include it when calling the method. Now Python passes automatically for us. So let's define a method, and this is the code which has to be written inside a class definition. Like define age, self, and the number, and we are calling a method get underscore age 23. So this is a method which automatically Python passes us. We don't have to include all the time we call a method. Now we are calling an object methods. we have to append the method's simple name to the object reference using the intervening dot operator. Now it provides arguments to the method within the closing enclosing parentheses. Object reference dot method name of argument list or object reference dot method name. Now, let's say we have a called a rectangle object of 150. The area of the rectangle where 100 takes the length and 50 takes the breadth. So as shown, we can use it dot notation to invoke the new rectangle's get area in order get area method in order to compute the area of a rectangle. Now, while deleting instances, no need to free. Like when you're done with an object, you don't have to delete it or free it explicitly. Python, it has automatic garbage collection. It will automatically detect when all of the references to a piece of memory have gone out of scope. Now it automatically frees that memory. Generally, it works well, but few memory leaks are possible, and there's also no destructor method for classes. Now coming to object attributes and methods examples, the object attributes is stores the data for the object. Like taxi, it has got driver, one duty, and the num passengers and locations. These are the attributes of object taxi. With the object methods, it defines the behaviors of an object. Like example, let's consider the same taxi that pick up, drop off, go on duty, go off duty, get driver, set driver, and get the number of passengers. These are the methods. Now we are syntax for accessing attributes and methods. So let's consider student and let's say Python and age is 14. So we are accessing the attribute full name of that is Python and we are accessing a method age that is 14. Now coming to encapsulation. Encapsulation here, methods and variables are treated as a single entity class. So let's try to understand what is encapsulation. So important advantage of object-oriented programming is that it consists the encapsulation of data. And we can say that object-oriented programming, it relies heavily on encapsulation. So the term encapsulation and abstraction, also known as the data hiding, are often used as synonyms. So they are nearly synonymous, but they can be abstraction is usually achieved through encapsulation, and the data hiding and encapsulation are the same concept. So it's correct to use them as synonyms. So generally speaking, encapsulation is a mechanism for restricting the access to some of an object's components. This means that the internal representation of an object, it can't be seen from outside of the object's definitions. Now, access to this type of data is typically achieved through special methods like getters and setters. So by using solely get and set methods, we can make sure that the internal data, it cannot be accidentally set into inconsistent or invalid state, where C++, Java, and C rely on the public, private, and protected keywords in order to implement variable scoping and encapsulation. And it's nearly always possible to circumvent this protection mechanism. Now, encapsulation is wrapping of the data and functions into a single unit of that is class, and it hides the information, and it is an integration of data and operation into a class. So encapsulation is basically hiding the functional details from the object calling it. You're hiding the functional details from the object. So let's consider an example of a capsule, and we have let's consider some another example called, like if you generally ask a question like, can you drive the car? Yes, I can. So how does an acceleration work? So these details are encapsulated and they are hidden from the driver. So if we ask a person, a random person, like, can you drive the car? Yes, I can. The person, it's up to the person. And if we ask how does an acceleration work? The principle behind the working mechanism of an acceleration. So these are the particular detail which are hidden from the driver. So this is the example of an encapsulation. Now it is the inclusion of property and method within a class or an object in which it needs to function properly, and it enables the reusability of an instant that is already implemented within the class, within a new class, while hiding and protecting. It has both the duties. It has to hide the functionality. At the same time, it has to protect the method and properties from the client classes. Now, the class is a kind of container or capsule or a cell which encapsulates a set of methods, attributes, and properties to provide its indented functionalities to other classes. Now, in that sense, encapsulation it also allows a class to change its internal implementation without hurting the overall functioning of the system. Now, the idea of encapsulation is to hide how a class does its operations while allowing requesting its operations. Now, the sole work it does is to hide how a class does its operations and without actually affecting the functionality and method. Now, let's consider an example. Let's say we have a class called date, and the date, day, month, or an year, and then you need to define another class called person that has the following attributes: the first name, last name, and birth date. So in this case, we can instantiate an object from a class date inside a person. Now, encapsulation, it ensures that the structural changes remain local, and it changes the class internals that does not affect any code inside and outside the class, and it changes methods implementation that does not reflect the clients using them. Encapsulation, it allows adding some logic when accessing a client's data. Let's say validation on modifying a property value, and it hides the implementation details, which reduces the complexity, and it makes the maintenance easier. And coming to public, protected, and private data. So if an identifier it does not start with an underscore character, it can be accessed from outside. So that is, the value can be read and changed. Now the data can be protected by making members private or protected. Now instance variables names, they start with two underscore characters, and this cannot be accessed from outside of the classes, and at least not directly, but they can be accessed through private name mangling. That means private data A can be accessed by the following name construct: instance underscore name dot class name underscore A. And if an identifier is only preceded by one underscore character, it is a protected member. A protected members can be accessed like public members from outside of the class. And let's consider an example of class encapsulation, taking object as an argument. Now we are defining init function self abc, and we are defining self dot public as A, self dot underscore protected as B, and self dot underscore private as C. Now the following interactive sessions shows the behavior of public, protected, and private members. Now let's say X is encapsulation of 11, 13, and 17. Now we are calling X dot public, it's 11, then X dot underscore protected, it's 13, and X dot underscore protected is, we are actually assigning the X dot protected value, we are changing it as 23. So now if we print X dot underscore protected, it displays at 23. Now X dot underscore private, here it displays an attribute error which stating that encapsulation object has no attribute private, since we have changed this protected to 23. We have done some modifications. Now the following table shows a different behavior: public, protected, and private data. Now name, it is a notation of public. Behavior is it can be accessed from inside as well as outside. Underscore name, it comes under the notation of protected. Now it is like a public member, but there should not be any directly access from an outsider. And underscore name, it is a notation of private and it can't be seen and accessed from outside. Since we have accessed earlier some value 23 from outside, so private, it can't be seen or accessed. And coming to the other basic concept, that is inheritance. It is a process by which objects of one class, they get the properties of objects of another class. Now, inheritance is a way of organizing classes. It is a term which comes from inheritance of traits like an eye, color, hair color, and so on. So now, the classes with properties in common, they can be grouped so that their common properties are only defined once in a parent class. Now, coming to superclass, it inherits its attributes and methods to the subclasses, and the subclass, it can inherit all its superclass attributes and methods, besides having its own unique attributes and methods. Now, it is a powerful feature in object oriented programming, that is inheritance, and it refers to defining a new class with little or no modification to an existing class. And the new class is also called the derived or child class, and it is the one from which it inherits, that is called the parent class or base class. And now derived class inherits the features from the base class and which adds its own new features to it. And this also results into reusability of code. This is a syntax called class of base class object, the body of the base class, and then class derived, which is inherited from the base class. This is the body of the derived class. Now, inheritance, it allows child classes to inherit the characters from existing parent classes, and it has got its own attributes, that is the field and properties, and the operations are nothing but methods. Here, child class, it can extend the parent class and it can add new fields and methods. It can redefine the methods, that is modifying the existing behavior. And a class, it can implement an interface by providing implementation for all its methods. And inheritance, it expresses commonality among the objects and classes, and it allows code reusability, it highlights the relationships, and it helps in code organization. And it is a mechanism in which one object acquires all the properties and behaviors of a parent object. Inheritance, it represents the as a relationship, which is also known as, sorry, is a relationship, which is also known as a parent-child relationship. And like animal, it is a mammals, reptiles, or birds. And terms are used in inheritance are subclasses, child classes, or derived and extended classes. Now, these all the classes are inherited from another class. Coming to superclasses and the parent classes or the base classes. The superclass is a class from where a subclass inherits the features. And reusability, as the name specifies, reusability is a mechanism which facilitates you to reuse the fields and methods of the existing class, where you can create a new class and you can use the same fields and methods already defined in the previous class. Now, the types of inheritance are single, multiple, multi-level, hierarchical, hybrid, etc. Where single is nothing but your class A is defined from class B, and class B is defined from that of class, it is inherited from class A. Where multi-level, class C is inherited from class B, where class B is inherited from class A. Indirectly, class A is also inherited from class A. And hierarchical is nothing but all the child classes B and C, they're inherited from a single base class, that is class A. So class B is also inherited from class A, whereas class is inherited from class A. And multiple is that of one class is inherited from many, one child class is inherited from many base classes, where class C is inherited from class A, And class it's also inherited by class B as well. Now hybrid class, where it is a combination of single and multiple inheritances or multiple or multi-level inheritances. Like class D, it can be inherited from class B and C, and class B and C can be inherited from class A. Now, let's consider this base class and derived class. Here, base class has got its own feature 1 and 2. These are the features of base class. And the derived class, which is inherited from that base class, it has its own features 1, 2, and 3. And these are the features, 1, 2 are the features of the base class, which is accessible to derived class because of inheritance. And feature 3, it is the own feature which is defined in the derived class. So while designing a inheritance concept, you have to keep the following key points in mind. That is, a subtype never implements less functionality than the supertype, and inheritance should never be more than 2 levels deep. And we use inheritance when we want to avoid redundant code. Now, the two built-in functions is isInstant and isSubclass, which are used to check the inheritances. The function isInstance, it returns true if the object is an instance of the class or other classes derived from it. Now, each and every class in Python, it inherits from the base class object. And this is a programming representation of inheritance. That is the syntax of inheritance class, subclass name, it extends superclass name, and the methods or fields are declared inside the constructor. And let's consider an example of class employee, and the salary is, let's say, about 40,000. And the class programmer, it extends employee, and the bonus is around 10,000. Now we have to declare a public static void main, and the programmer have to declare a new value, a new name for the programmer. Have to display that programmer salary is like 40,000, and the bonus of the programmer is like around 10,000. So the output is displayed onto the screen as the programmer salary is 40,000 and the bonus is around 10,000. So the person with the name and address are it's generally considered as a base class, and the derived class is that of, let's say, derived class 1 is that of a employee, and it states that in which company he's working and what is the salary, and then the name and address. And then coming to derived class of student, let's say it's school. Let's say the name and address of the student and school of the student. So these are the functionalities of base class and the derived class. Here, base class, it has name and address. So this is a functionality that is common in both the derived classes. The derived class 1 employee has got name and address, but the derived class 2 student, it has also got the name and address. Now, example of single inheritance. Single inheritance is one class which inherits from another. Let's say the superclass is parent, and the subclasses like the descendants. Superclass is nothing but the ancestor, and the subclass is nothing but the child class, which are descendants, and they are like, say, a parent class, it has got an account example. Then the account the account consists of balance, name, and the number, and the withdraw and the create statement. So by using this inheritance relationship, the same is transferred to the subclasses or the descendants, that is a child class. And these are the savings and the checking. This is the inheritance relationship. And the same account information is transferred to the subclasses, which includes which adds a new functionalities, that is savings and checking, from the child class. Now, multiple inheritance. Multiple inheritance is a class which can inherit from several other base classes. Now, let's say flying thing and animal. And here flying thing, let's say an aeroplane and helicopter. And animal, it's wolf and horse. And let's say bird. Bird is an animal. It has got few functionalities of animal, as well as it's a flying thing. So it is inherited from several other different classes. This is an example for multiple inheritance. Now, an inheritance hierarchy. So if we consider a vehicle, and it can be a motorcycle, a bus, and let's say an automobile. Now it can be a sedan or a sports car, but bus, it can be a school bus or a luxury bus. Now here vehicle, it acts as a superclass, and these all are the bus, the motorcycle are its subclasses. All these are derived from a single base class vehicle. Now coming to abstraction. Actually, class, it has got two types, that is concrete class and an abstract class. Concrete class, where it can be instantiated directly, and abstract class, it can't be instantiated directly. Now coming to data abstraction, it refers to the act of representing important description without including the background details or explanations. And abstraction is a design principle. It is the process of removing characteristics from something in order to reduce it to a set of essential characteristics. Now, through the process of abstraction, a programmer hides all but the relevant data about a class in order to reduce the complexity and increase the reusability. Now, abstraction is a basic representation of an concept. It's just an act of representing important information and to hide all the background details or explanations. Now, abstraction, it allows programmers to represent complex real world in the simplest manner, and it is a process of identifying the relevant qualities and behaviors an object should possess. In other words, it represents the necessary features without representing the background details. And we should always use abstraction to ease reusability and understanding for the design and enabling extension. Now, when we design the abstract classes, we define the framework for later extensions. Now, an abstract class, which is declared with the abstract keyword, it cannot be instantiated. Now, it can only be used as a superclass for other classes that extend the abstract class. Abstract class is a design concept and implementation. It gets completed when it is being really when it is being realized by a subclass. Now, let's say a person has got his own date of birth, name, as well as an address. Now, concrete class and abstract class. Uh, Concrete class, let's say a teacher, that it can't be instantiated directly. And now, abstract class, let's student. Concrete class, it can be instantiated directly, and an abstract class which can't be instantiated directly. So let's take an example of teacher and a student. Both are persons. Teacher, it had the teacher class. Teacher has got its own date of birth, name, address, specialization, academic title, etc. Student, it has got its own date of birth, name, address, GPA, courses, etc. Now, these can be instantiated directly. So these are the type of classes which are involved in abstraction. Now, an abstract class, it is a class that do not have any direct instances, and an abstract operation, it is an operation that it is incomplete and it requires a child to supply an implementation of the operation. Like, let's say a shape of abstract class, then we have to draw the abstract class shape. This is an abstract class, and this is the operation of the abstract class. Now we have to consider two objects like circle and rectangle, which performs the abstract operation of draw. And it is basically hiding the implementation and gaining access to the functionality by exposing by extend keyword. And an abstract class is a class that may not have any direct instances, as we have seen earlier, and it is an operation that it is incomplete, and it always requires a child to supply an implementation of the operation. So we have seen earlier in this format. Now, Coming to polymorphism. Polymorphism is the ability to take more than one form, and I have already stated earlier, poly means many and morphism means forms, and it allows us to write generic reusable code more easily. Now, polymorphism in Latin word, it is made up of poly, which means many, and morphs means forms. From the Greek, polymorphism means many, and it indicates a shape. And this is something which is similar to a word having several different meanings depending on the context. Generally speaking, about polymorphism means that a method or a function which is able to cope up with different types of inputs. Now, let's say a simple word could. It can have different meaning depending where it is used. Now, if anybody says cut to this people, let's say surgeon, the surgeon would begin to make an incision, and hairstylist could begin to cut someone's hair, and actor would abruptly stop acting out the current scene, waiting for directional guidance. So the word cut, it has got different meanings. So one word, it has got a lot of meanings. It takes a lot of forms. This is an example for polymorphism. Now, the polymorphism, it is a generic term that means many shapes, and more precisely, polymorphisms means the ability to request that the same methods can be performed by a wide range of different types of things. Now, in object-oriented programming, polymorphism is a technical issue and a principle, and it is achieved by using many different techniques named method overloading and operator overloading and method overriding. Now, in object oriented programming, polymorphism is the characteristic of being able to assign a different meaning to a particular symbol or operator in different contexts, especially to allow an entity such as a variable and a function or an object to have more than one form. There are two kinds of polymorphisms, overloading and overriding. Overloading is two or more methods with different signatures, and overriding, it replaces an inherited method with another having the same signature. Now, polymorphism, if one task it is performed by different ways, it's known as polymorphism, as I have stated earlier. For example, to convince a customer differently to draw something like shape, triangle, rectangle, a cat speaks, meow, and a dog barks, woof, etc. And let's say polymorphism, it is a present method that can have many definitions. Like it can present a method. It has got a many, like say, definition or terminology, and it is related to overloading, that it can compile time polymorphism, and it can at the same time it can run time polymorphism, and overriding, it can run time polymorphism or dynamic polymorphism, and it has got its own syntax, say get price and get price of the string name. Now, polymorphism, and it has got like an object, it has multiple identities based on its inheritance tree, and it can be used in several different ways, and the encapsulation, inheritance, abstraction concepts are also very related to polymorphism. Now, in Python, two or more classes could each have a method called output, and now each output method would do the right thing for the class that it was in. And one output might display number output.number in one class, whereas it might display a name output.text in another class. And it is the ability to look at a class in its parent's image. Now let's see the robot example throughout the following few slides. So let's display the example of robot. Now, it is a class that you cannot instantiate from. However, we can use it to dominate and specify how the minimum requirements in an inherited class should be. Like let's consider an example of a robot class. It's public abstract class robot. And we have to public virtual abstract void move. Here we are abstracting the move needs. Now let's say public class of legged robot. We are public overriding the void move, and this is the actions of legged robot to move. Now here we are considering public class wheeled robot of that robot. Now we have to public override void move, and we are considering the actions of wheeled robot to move. Now let's say we are public void move. We're trying to move the robot with a dot move, and we're trying to move all the robots that are of leg robots and wheeled robots. Now we are trying to move the robots of two different types using the abstract keyword. So here we are just we are using the abstract keyword to dominate and to specify how the minimum requirements in an inherited class should be. So it is a particular class which cannot be instantiated. Now let's consider another example, that is of shape, where we can draw, and shape, it has got its own functionality to draw, like a circle. The objects are circle, triangle, square, and they have inherited the functionality void draw from that of a shape. And so here, rectangle object, it is an object of shape, so it has to draw rectangle, where square has to draw square, and circle, it has to draw circle. Now what is an operator overloading? So Python operates work for built-in classes, but same operator, it behaves differently with different types. For example, the addition operator will perform arithmetic addition on two numbers, merges two lists, and concatenate two strings. This feature in Python, it allows the same operator to have different meaning according to the context, which is called an operator overloading. And one final thing to mention about operator overloading is that we can make customer methods to do whatever we want. And however, the common practice is to follow the structure of the built-in methods. Now, explanation for operator overloading with a sample program. What actually happens is when we do like person1 and person2, like person1 minus person2, it's subtracting. So the Python will call p1 dot underscore sub p2, which in turn is point dot subtraction of p1 and p2. So similarly, we can overload both we can overload the other operators as well. So the special function that we need to implement, it is tabulated below. Like say the operator addition, the expression is p1 plus p2. Internally, it is declared as p1 dot add p2. And if we want to perform subtraction, it's p1 minus p2, p1 dot sub of p2, and the multiplication p1 times p2, p1 dot the mul function of p2, and the power p1 raised to the power of p2, it's p1 dot power of p2, and division p1 divided by p2, p1 dot true diff of p2. So these are examples of operator overloading. So that's the end of the presentation. Thank you.